Here's the solution to the second problem, and I'll read the second problem. I'm going to go off camera for a second. Do the following series converge conditionally, absolutely, or diverge? So again, here, all you need to say is answer that question. Do they converge conditionally, converge absolutely, or diverge? You don't have to say anything about what they converge to. So, sorry. Okay, so the first one, what I had in mind here was a root test, but some people had some interesting ideas which I accepted. Let me just finish writing that down. I got interrupted, I guess. So I'm going to use a root, and I'll talk about the other ideas. So it's going to be the kth root of the absolute value of e to the k plus 3 to the k over 4 to the k. So I want to take this limit, and that's going to be equal to rho. Okay, and this is going to be equal to the limit k goes to infinity. Absolute value takes away this. That's negative, so that's going to go away. So it's going to be e to the k plus 3 to the k over 4 to the k, all to the 1 over k. This limit's going to be infinity, as you'll see. Get e to the k plus 3 over k to the k, which is 1 over 4 to the k over k. Cancel. And that's going to be, this is going to go to infinity. So this limit is equal to infinity. Therefore, by the root test, rho is equal to infinity, which is greater than 1. Therefore, the series diverges. Okay, to me, that's the simplest way to answer it. There's other ways. What some people did is write the series down, and they did something like this. They said, oh, this is equal to e to the 1 plus 3. This is when k is equal to 1 over 4 minus e squared plus 3 over 16. And basically what they, oh, this is all to the k. So this is to the 1. This is squared. And basically what they said is that each term is greater than 1. Therefore, the limit, the nth term test, the series diverged. And I accepted that, though this is definitely a much better answer right here. So I'm just kind of letting you know there's other ways to look at that. Okay, this one, there's really only one way to look at it. And because it's got factorials, you want to use the ratio. So I'm going to set up the ratio limit and be patient while I do it. So absolute an plus 1, I'm sorry, ak plus 1 over ak. The absolute's going to take care of the minus signs, so I'm not going to bother with those. I plug in everywhere there's a k, I increase it by 1. And that's going to be 2 over k plus 1 quantity, factorial, all over the series itself. This is going to be 2k plus 2 factorial. So over here, I'm going to gather like terms. I'm going to get a 5 to the k plus 1 over k plus 1 factorial, 2k plus 2 factorial. Sorry, I'm going to invert and multiply first. So when I flip things over, I get 2k factorial over 5 to the k. Okay. And what I'm going to do is just gather like terms now. Remember, if this limit is greater than 1, I have divergence. So I'll put the 5's together. I'll put the 2k's together. And I'll put the k plus 1's together. Okay. So I've gathered the like terms, and now I simplify. This is going to be 5k plus, this is going to just be 5 because I'm going to subtract k there. I'm going to get just a 5 there. This is going to be 1 over 2k plus 1 times 2k plus 2. This will be k plus 1 on top, k plus 1 here after cancellation. So that's going to be lim 5 k plus 1, k plus 1 over 2k plus 1, 2k plus 2. Now I'll show you the algebra from here and here how to simplify on the next page. So I multiply this out. And what I'm going to get is a polynomial. So this is k squared plus 2k times 5, which is 10k plus 5, over 4k squared, 2k, that's 4k, 6k, and then plus 2. And notice I have 5k squared over 4k squared. Using L'Hopital's, this is going to be equal to 5/4. That's greater than 1. Therefore, by the ratio test, the series diverges. Okay, but now I want to go over the algebra here. So the ratio test, the series diverges because the ratio limit's 5/4. Okay, now what a lot of people did is the mistakes in algebra with this and this. So I'll go over that. So let's see. There we are. So I'm going to look, I'll just recopy. I'm going to look at 2k factorial over 2k plus 2 factorial. And then I'm going to look at k plus 1 factorial over k factorial. Now the idea is that this is equal to all the numbers up to k plus 1 multiplied by one another. That's all the numbers multiplied to k times each other times k plus 1. So over k factorial, that cancels. And a good way to see this, if you forget, let k equal something like 3, and we'll get 3 plus 1 factorial over 3 factorial, 4 factorial over 3 factorial. If you write that out, you get this. That's equal to 3 factorial times 4 over 3 factorial, which is just 4. In other words, k plus 1 factorial. Okay. Well, this is similar. This is equal to all the numbers up to 2k. This is equal all the numbers up to 2k plus 2. So we go to 2k and then go 2 more. Okay, that's all this here is just 2k factorial, and so is this. Those cancel, and that's what I'm left with. So again, going back to the problem as given, I gathered like terms. I wrote this, canceled out, reduced it to 2k plus 1, 2k plus 2, did the same thing over here, and that's how I got those things.